and welcome to the Pacifica Taco Bell in Pacifica, California. People from all over the Bay Area come here to eat tacos, burritos, chalupas, and other menu items that you just can't find in Mexico, like the nacho cheese Doritos Locos Taco. Being right on the sands of Lindamar Beach, many people also come here to surf. But we're here today to do some carpool chemistry. Today, we're going to look at a single replacement reaction and the activity table. Let's say you have a compound, an ionic compound, sodium iodide, and you react it with potassium. What's going to happen? Well, what happens is this iodide is currently, iodide being a -1 charge and sodium being a +1 charge, is currently ionically bonded to sodium. Iodide's going to take a look at potassium and it's going to say, hey, I'd rather hang out with potassium instead. And so we're going to have potassium iodide +1, -1, same ratio, and then left out all by its lonesome will be sodium. Here's one way of looking at this reaction. I once had a crush on a girl, but for some reason she just didn't feel the same way about me. You might say that I was not quite high enough on her what chemists call activity table. Here's the activity table of the elements. Well, elements like this, for example, iodide, would rather hang out with potassium than sodium because potassium is higher on the activity table. Here is potassium up here, here's sodium down over here. With people, some girls might place guys that drive fancy cars, have a lot of money, and dress in fancy clothes on top of the activity table. Whereas some girls place attributes such as knowledge of chemistry, basketball skills, and lame jokes at the top of their activity table. So what is it that places elements such as lithium, rubidium, and potassium on top of the elemental activity table? The key is their great willingness to give away their outer shell electrons during a chemical reaction. Notice how the elements at the top of the activity table, lithium, rubidium, potassium, they all have one electron, just one single electron in their outer energy level, lithium, potassium, rubidium. They want to get rid of this one electron really bad in order to attain a stable outer energy level of 8 electrons. As you can see, if potassium gives away 1 electron, the new outer energy level will have 8 electrons. They want to get rid of this 1 electron really bad in order to attain a stable outer energy level of 8 electrons, or in the case of lithium, 2 electrons. Nonmetals such as iodine, here's iodine over here, have 7 electrons in their outer energy level and want to get 1 more really bad in order for them to have a stable 8 electrons in their outer energy level. If an element such as potassium comes along and will even more readily and generously give its electron to iodine, iodine will leave sodium and bond with potassium instead, as we see right here. Has this ever happened to you? If so, don't despair. You just underwent a single replacement reaction. Unbeknownst at the time, it often works out for the better. That's how the activity table affects a single replacement reaction. Thank you for watching. From the Pacifica Taco Bell, this is Carpool Chemistry.